Hello again, you sick, twisted weather freaks, and welcome to another fun-filled, action-packed, and really exciting edition of This Week in Weather. I'm your host and meteorologist, DT from Weather Risk, your captain of chaos, your colonel of confusion, your commander of catastrophe. Let's talk about what's coming up for December. It looks exciting. So, I guess I'll call this one incoming, because, it's time to take cover, because it looks like the shit's going to hit the fan here. So let's see what's going on here. All right, first we'll start out by taking a look at this slide. And this here is the pattern and how it develops here over the next 4 or 5 days. This takes us out to day December 6th. And you can see currently we have this big trough here on the west coast of the United States. This is known as the negative P&A, west coast trough, and there's your ridge in the Midwest here. So that's why it's been so mild east of the Mississippi River relative to normal, but it's been quite cold and stormy in western Canada along this trough here. A lot of big precipitation events in the Pacific Northwest and in Northern California as well. So what happens is by the time we get to, let's say, December 4th, so this trough has moved through, all right, and a piece of this energy breaks off and it comes right across the upper plains of the Great Lakes, and it ends up here by December 4th. There's our polar vortex. Notice the vortex is way up here at the top of the screen December 1st, tomorrow. But by December 4th, it's down here in central Canada, which is a significant development. It means the polar vortex is now, at least it is split, though we have one in North America and one in Eurasia. So the vortex has split. So that's why when we talk about the polar vortex splitting, it's always a sign that the cold air is coming into North America. Sometimes the polar vortex can be found over in Asia, Eurasia, Siberia. And when that happens, you never get cold air in North America and you have mild winters. But that's not the case here. Also notice, you see the trough here? Look what the difference is here. We have a monster ridge which is formed here in Alaska. See that difference? Totally different. This ridge here has moved eastward. Now the southern piece of this trough is broken off and still hitting the west coast of North America. And we still have the ridge, but the ridge is being suppressed. You see how it's getting pushed southward here a little bit? See, it's getting pushed south. And eventually, as the vortex gets really powerful and big, the ridge gets flattened even more. And now you have a direct flow of Arctic air into the northern United States, into New England and the Great Lakes. But we still have the mild Pacific jet stream coming along this black line here through the southern states, where it's still remaining pretty mild across the Gulf Coast states. Meanwhile, you're still getting a lot of energy from this trough. This is a classic La Nina trough here. So you're going to get low pressure coming out of this trough, as you can see, then travel in between these two black lines, and that's when you get your storminess. And also you can notice here's the blocking pattern developing in Greenland coming in from Scandinavia. Very quite pronounced. All right, now let me show you the temperatures. This was the temperatures here. How cold we're talking about. This is November 29th. Yes, November 29th. Yeah, this is a couple days ago, and you can see here that the cold air is quite impressive in Canada. Okay, just getting into the northern Rockies, and then down the bottom right, these are the max temperatures on November 29th. So again, notice everybody east of the Mississippi River, pretty mild here for late November, but seasonally cold temperatures. But it's going to get a lot worse. In fact, let me show you the temperatures here as of November 30th. Today, this is the morning temperatures on the left and the min temperatures on the right. This is the plains, the Midwest, and I didn't do the eastern United States because the cold air is not here yet. But you can see, look at the min temperatures in the Rockies and the upper plains, single digits and teens up there. So it's cold air. I mean, it's not record-shattering cold, but it's cold. Wintertime cold, no doubt about it. And then look at the max temperatures. Now this isn't pretty impressive. With they don't have a lot of snow on the ground in the Dakotas and Minnesota yet. They still have temperatures in the single digits and teens, and the max temperatures in the 20s and 30s. As far south as the Missouri-Iowa border into central Illinois, Indiana, it's pretty chilly. So not bad for mid-November, to say the least. All right. Now, let's talk about what's going to happen here. In order to understand it, we have to go back to our teleconnections. I bring this slide up every time because I think it's a very good, useful slide here. So the teleconnections, of course, are the jet stream patterns. There are special kinds of jet stream configurations which exist all around the world. Now, some teleconnections last the whole season long, like El Nino or La Nina, okay, or the negative PDO, Pacific Decade Oscillation. But some are subseasonal. That is to say, they go from week to week out to 2, 3, 4, 5, 6 weeks. More than just a week, but not more than a couple of months. So it's what we call subseasonal, or S2S. That's the new term we use here in the weather business. Now, there are four primary teleconnections we look at here in North America. We have two on the Atlantic side. See the red line? That's the Atlantic side to the right of the red line. You got that? And then to the left of the red line, we have the Pacific teleconnections. So we have the Arctic oscillation on the Atlantic and the North American oscillation, which is either the Greenland low when it's positive or the Greenland block when it's negative. And on the Pacific side, we have the PNA, which is the West Coast ridge or trough, depending on the position, and then the EPO, which is the Alaskan ridge or trough, depending on the position. And of course, there are combinations. On the Atlantic side, here's the Atlantic combinations, the NAO and AO. So positive, neutral, and negative. So of course, AO positive, then you have the NAO positive, neutral, negative. So it's all different combinations. Like for example, you can have a neutral AO but a positive NAO. Okay, you can have a neutral Arctic oscillation but a negative NAO or Greenland block. So there's all these different possible combinations. You can see there's 9 of them. Then on the Pacific side, you have 9 other different possible combinations, again with the PNA, the West Coast ridge or trough, and the Alaska ridge. All these different possible combinations. So these are things that meteorologists have to look and find when they're trying to figure out the pattern beyond the next few days. All these different combinations. So that's what makes it kind of tricky, but also very, very fascinating. And the reason why we look at that is because, in particular, I've showed this before, but when you have La Nina and you have a positive NAO, let me show you what I'm talking about here. When you can see that you have very warm temperatures here, and when you have a positive NAO during the winter months, look how warm it is in December, look how warm it is in January. But when your NAO is negative here, look how much colder it is. This is a totally different pattern from this. You see the difference? It's striking. So the NAO position is very important during the winter months with La Nina in particular. Now, typically what you want, if you like cold and snowstorms in the Ohio Valley, the Tennessee Valley, Mid-Atlantic, New England, this is what you typically want to see. You want to see a negative EPO and a positive PNA on the west coast of North America. That means you're getting a flow from Siberia and the North Pole into Canada and a big ridge on the west coast. So you're getting extra cold air. And when you have a negative AO or NAO, that means you have a lot of blocking in Canada and the Arctic regions, and the cold air can come south. So let me show you what this looks like. This here is the surface map and snowfall map from the January 1996 blizzard. Many of you may remember this storm. This was a classic Gulf of Mexico storm, or what we refer to as a Miller A type of storm. All right, and you can see the huge amounts of snow. So even in Richmond area, we had 20 inches of snow, and of course you had more than that up in D.C. and Charlottesville, Philly, New York, so on and so forth. And of course, the huge amount of snows were located in the Shenandoah Valley. Yeah, that's actually over 40 inches. I mean, the Shenandoah Valley got absolutely crushed in northern Piedmont. Even had 2 feet of snow in Roanoke. A pretty nice snow there, 2 feet in Lynchburg. It was a big, big freaking storm. Now let's look at the upper air map and see what that looked like. This is the 500 millibar map. You can see right here. Now notice a couple things here. When the event started, we had a ridge on the west coast. You see the ridge here? See how the lines go up and then down? There's your ridge. And look at this feature right here. That's your 50-50 low. It's also referred to as a Newfoundland low. It's over Nova Scotia, Canada, Newfoundland. What this feature does when you're looking for snowstorms is it forces the energy to go underneath it. You know, sometimes you get storms coming out of the Rockies which go to Chicago, which is great if you live in Chicago, but if you live in Pennsylvania or New England or Virginia or Kentucky, that sucks. So, but when you have a 50-50 low, this low here, this piece of energy in the southern jet stream is forced to stay to the south. You see how it stays so far to the south? And then it ends up reaching the coast and it bombs out and you get a huge snowstorm. So that's why this feature here is really important. And of course you have a negative NAO as well. So this is a schematic of what this looks like, the blizzard of 1996. Now this here is a nice loop of the December 2000 snowstorm. And this is the Millennium snowstorm, and this was a Miller B snowstorm which dropped a lot of snow from DC northward. In particular, actually I think it was from Allentown east into New York City and Boston and New England. It really didn't hit west of Philly. It was a very, very tight snow gradient. But here you can see also what happens. At the beginning of the event, you have this 50-50 low. See that? And this piece of energy is forced to fall behind it. Let's watch it again. There's your 50-50 low. There's the energy going underneath it behind it. See how it drops down? So this 50-50 low is very important. There's your ridge on the west coast. So we have that. There you go. And you have a lot of blocking up in Canada and Greenland. So this is a classic situation. Okay. Here's another one for you to look at. This was the January 1966 historic blizzard that just bombed the entire East Coast with monster snows and incredible cold. Now there was actually a storm behind this one on January 27th, 28th, but which also dropped significant snow in Virginia, North Carolina. But if we look at the beginning of this event here, let me bring it up. You can see there's your 50-50 low. See it? And here comes the next system. See how it's forced to drop underneath it? Let's look at it again. 50-50 low, this piece of energy going underneath it. See what it does? It goes right through Virginia, North Carolina, goes boom, and just hammers the entire East Coast with a monster snowstorm. It was glorious. Okay, now, here's your original West Coast at the beginning of the event. Look at the blocking up here. Very impressive blocking up in here. You can see that. Let's look at the beginning of the event again. There it is. You can see the blocking here. Huge negative anomaly. And one more time, at the beginning of the event, there's your West Coast ridge. Look at the block right here. Massive. A negative NAO in Quebec, Canada. Big, big deal. Big, big freaking system. Great winter storm. One of the great ones. Now, this is the February Mid-Atlantic New England snowstorm of 1978. Great, great storm as well. And a lot of people are very familiar with it. And here we can look at the upper schematic and see what's going on. And once again, there we have our 50-50 low. Let me call it, take my arrow from here, cut it out, bring it over here. There's the beginning of the event. We'll go to the beginning. And there it is, February 7, bombing out. February 8th. Starts February 5. There's your 50-50 low right there. You can see it. Oops, moving away. There you go. And then this system, the one that drops down, is forced to go underneath it. Let's run it again. 50-50 low. Look at the system dropping down underneath it. See how it does that? Very impressive. Now, interestingly also, you notice you have original West Coast, but it collapses when the event begins. The energy comes in at the Pacific, so the West Coast ridge is destroyed. And what about our blocking at the high latitude? Let's look and see. Pretty significant blocking here. You can see in Greenland as well. One more time, you can see it, so you can don't miss it here. February 5. Yep, there it is. Nice block there in Greenland. So that was a great storm. All right, let's take a look what's going to happen right now, 2022. Here is the Arctic Oscillation. Look at this thing tank by December 15th. All the models tanking it. Here's the NAO. Look at this thing freaking tank. December 10th, okay? Now remember, as you go towards the end of the time frame, you're always going to have a tendency to move back to the mean. So I don't know if it actually is rising here at the end of the time frame, December 15, 17. Remember, it tends to go back to the mean. That doesn't mean that's right. So that's the first thing to keep in mind. The other thing is, look at the EPS spread here. 50 different models in the European. Look at this sucker. Arctic Oscillation goes negative, extremely negative by December 5, and this thing is tanked through December 15th. Holy cow! I mean, good googly moogly. I am impressed. I'm getting impressed easy, and this thing is tanked. Look at the dark purples in here, 5s and 6s. Oh my God. Okay, here's the NAO. Wow. I mean, wow. Look at this thing. I'm impressed. And here's the thing. You want to know the kicker? Here's the thing. This is from November 22nd, only 8 days ago. You see how different this was? I see how everything was up in the air, the Arctic Oscillation, NEO. Some were negative, some was positive. You know, the yellows and the browns and the reds, they're positive. There's not real consensus here. Look how this thing has changed. Now, if you want to look at the new extended one, this is the next 35 days. This takes us to January 4. Here's the Arctic Oscillation, consistently negative. And again, once you go towards the end of the month, you see some positive and neutral in there, moving towards the mean. I don't know if that's right or not, but you can see very, very strong tendencies here for negative. Here is the NAO, same sort of thing, strongly negative to Christmas. Then it kind of goes towards neutral, which may or may not happen. Remember, as you go towards the end of the time frame, the models always had a tendency to go towards the mean. So, back to neutral conditions. Okay, let's look at the Pacific side. Remember the Pacific side here, looking here at the Pacific side, the EPO and the PNA. So let's look at the Pacific side. All right, the PNA is strongly negative all the way through. Takes us to December 17th. Now it's rising a little bit. It's getting close to neutral, but it's not there yet. The EPO, which is negative in December 5, Here at the bottom of the graph, you can see that it rises towards positive. So negative is when you get your big Arctic blast, then it goes towards neutral. And then after December 10th, some models go positive, some models go neutral. So the EPO is up in the air. Let's look at the spread here. Here's the PNA. And again, very negative at the start of December, December 6th, December 10th, December 16th. Now we're beginning to see some positives showing up here. Okay, then it's up in the air here, some positive, some negative. So maybe there's a tendency towards positive a little bit, or at least neutral, after December 15th or 20th. And if we go to the EPA, if we go to the EPO, same sort of thing, strongly negative, which is great. Then it's a mixed bag after December 15th or 20th. Some positive, some negative. It's up in the air. Very uncertain here. As far as the MJO goes, look what happens here. Not much. Here's the GFS MJO. Let me bring this front. There you go. And you can see there it is, the MJO on the GFS, phase 8, and then it goes neutral circle, and then just around the neutral circle through December 14th. Here's the European, neutral circle. Not much of an impact. It's saying it's going to go to sleep, take a nap for a while. Here's the European extended, same sort of thing. Look at the red and blue lines. See how it goes into the circle? It just does a loop-de-loop. It's falling asleep. It's not doing anything. See, here's the European. This is the Australians. Same thing. Phase 8 and phase into the neutral circle. Takes a nap and falls asleep. It's not doing anything. That means of all the pieces we have to worry about as meteorologists, we don't have to worry about the MJO. It's going to be going to the neutral cycle here after the first couple of days of December. So we don't have to worry about that. Okay, now let's take a look at our models. Now this is day 8, December 8th. Now what's happened is that the thing has finally pushed on through. Let's go back to where we were, the models before. And you can see that this trough now has begun to knock the ridge down here as the polar vortex has gotten stronger. So by the time we get to December 8th, we have this. Now the ridge is still strong there. You see that? The problem here in the European, this is the date December 8th. There's our monster block. Look at this thing. Is this thing freaking massive? Holy crap. But the trough is still on the west coast. You see that? So this trough on the west coast means a ridge in the southeast. See that? This connects to this. This connects to this. So the low pressure areas come out of California, but they're forced to track along I-70. See that? And as a result, it looks like any precipitation that comes from this event is probably going to be further north and not enough for, let's say, my home area, Virginia or Maryland. It might be further north if we get anything out of it. There's our polar vortex here. So the front comes through, the cold air settles down December 7th and 8th. But here's the thing. Now this is the 18Z GFS. Now notice the difference here. You see the European, how big the ridge is right here? See that ridge? Now here is the 18Z GFS. It's flatter. See that? And as a result, also there's a disturbance in the northern jet stream, which is right here, which is not on the European. So I don't know what the GFS is jumping at here, but this indicates two lows taking a further south track and a more potential for something on December 8th or 9th. Maybe it's too early in the pattern. Maybe we have to get the southeast ridge out of the way. But the 18Z is showing something here and another short wave low pressure area here. So these are two things to watch here. I'm not convinced nothing's going to happen yet on December 7th or 8th when the front goes on through and it pushes to the south. I still think there's going to be an overrunning event here, but I could be wrong. There's your polar vortex and there's your monster block. Just impressive. Also notice the other thing. Look at the ridge forming here in Western Canada. And the European has a huge trough. See that? Big difference. European, GFS. European, GFS. So there's some differences here. Okay. Now let's go to the European day 10. This is the operational European day 10. Now you can see a ridge here in the Rockies, which is very nice. There's your monster block. And here's your 50-50 low. Remember how we talked about that at the beginning of my presentation? I'll have all the big winter storms on the East Coast have that 50-50 low. This thing is massive. And there you have a nice short wave, which is going to be forced to drop underneath it. See that? Notice there's no ridge in the southeast. You can see that? No ridge in the southeast anymore. So this comes on down to Tennessee, North Carolina, Virginia, and it goes boom, and you get a big East Coast snowstorm. That's what this is indicating. Now the surface map doesn't look that promising. I think this is wrong. Remember, this is day 10. This is 10 days out, okay? But there's your Arctic high, and there's your low, and you can see the cold air right here trying to get into it. So this is just developing. So I think this is underdone. If this is right, I'm not saying it is, but if this is right, and you get a short wave there with this kind of upper air pattern, this is going to go to the East Coast on December 10, 11, and 12, and it's going to go boom. I mean, it really is, if this is right. That's a nice looking map. And here's the next one. And this is, I posted this earlier on the Twitter page. Look at this. Here's December 10th and the 11th. There's your trough right along the Mississippi River Valley, exactly neutrally tilted. It's screaming snowstorm. There's your ridge on the Rockies on the west coast. Monster block in Greenland, which is moving westward towards Baffin Island. Baffin Island is that big island right here, by the way, in case you don't know it. And there's your 50-50 low right there. I'm telling you, I am excited to see this map. Now, I realize it's 10, 11 days out, but I mean, yeah, I want to see if that holds. I want to see if that's hold. And then finally, here is not quite finally, but this is December 12th. And again, now at this point, the European has actually negative anomaly, the green, a nice negative anomaly here, right along the Virginia, North Carolina coast. I mean, wow. This is just screaming big snowstorm if this is right. I don't know if it's right, but I think it is. And again, I really like the block. Look how the block starts here in Greenland, and now it's Hudson's Bay. See that? Westward moving negative NEOs, always a strong sign for an East Coast snowstorm. Just my opinion, and based upon the research as well and the experience. The polar vortex remains very weak. You can see this again. Here it is. The dark blue is the mean, and you can see it's very close. It's right along the mean and median. 30, 35, very, very weak, much weaker than last winter's, no doubt about that. And then here, of course, is your blocking patterns. This is my last slide here, and you can see again the red is blocking patterns, and the green is negative NEO. So all the way out to January 11th, the 6-week European, 45-day European, showing the vast majority of the pattern across Northern Hemisphere, North America, is going to consist of strong blocking and negative NEO, or the Greenland block. So if this is right, this winter December is going to rock. So it is a lot of data, which has me excited here, folks. I got to tell you, you can hear it in my voice. I'm looking forward to this. I want to see what's going to happen. I want to see if we can hold the pattern. Is it time to like go bonkers crazy yet? If you're a meteorologist and you'd like the subseasonal stuff, this is the time to get excited. If you're a regular person and you're trying to figure out what to do for next week and whatever, we're not at the point yet to freak out or anything like that. The pattern has potential. It looks great. Let's get to December 7th first and see what happens in the second week of December, because then I think we'll have a much better idea. This is meteorologist DT from Weather Risk. I will see you over on the Twitter page, over on the website, and then over on the Facebook page.